So we have in today something pretty unique. These are battery packs off fire breathing apparatus. They all suffer from what looks like PCB damage. It's probably from the moisture in the water when they're putting out fires. And what we're going to do on this one is clone the PCB completely and make brand new boards instead of repairing these, because this seems like it's going to be a fairly regular repair we'll do. And I don't want to be repairing damaged PCBs. I prefer to just make them. So you're going to learn today how we're going to clone a PCB. So these are the devices. The customer sent 5 in. We're going to repair 5. And inside you can see it's probably got I presume, heat resistant gasket. And it looks like 5 AAs, which would add up to 7.5 volts, which also makes sense because it says 7.5 volt and AA. These are the circuit boards inside them that have the damage, and there's no logic on these whatsoever. So it looks like it's just going to be probably current limit resistors and maybe a fuse here. And that'll just be for safety. So step 1 will be to remember where all components are and remove all these components to expose the PCB. Next is to feed the plug. There we go. Can I get on with some work now? So we will remove all the components, and then we're going to sand both layers of this PCB down to expose the circuit. Reverse engineer what it's doing, which looks very basic. Draw up the whole circuit and get this manufactured. And these tabs were probably best salvaging along with the battery springs. We're going to reuse the 2 pins. We're going to reuse the steel battery springs. We'll just dip these in vinegar and remove all the acid. These are just resistors. We'll know the size by measuring them, and they're all 220 ohm, so we'll just buy them new. And this I'm pretty sure is going to be a fuse, so we can spec that out. To test the fuse, I've just got a current limit of 1 amp at the minute, and it's holding it up. Leave it for 10-20 seconds at a time and increase the amperage as we go. So if we select amps and we just dial up here, 1.1, 1.2, and you just increase like this until the circuit basically cuts off. And there you go, it's actually died at 1.5 amps and open circuit. So this is very likely a 1.5 amp fuse. We'll repeat that test on the other ones to get an average, and then we know the spec of the fuse. Next we want to get this board as clean as possible, so we'll hot air, get everything nice and warm, then we'll clean down and sand enough to expose the circuit that we need to see. To get the accurate shape of this board, we just chuck it in a scanner, scan both sides, and with that scanned in now on both sides, we will just trace around this by just using the pen tool, going around. And with that now traced, we have the vector path for the board. We'll import that into the PCB design software. And to redo the schematic, it's pretty simple. You can see the battery spring here, which goes along to the positive. So you've got positive battery through the fuse, and then it looks like it goes up, down, up, down, up, down, all the way through 12 resistors, which when we measure them are actually 0.22 ohms, not 220 ohms, which makes a bit more sense. So you have a load of current limit resistors in a row, 12 of them. Then it comes out, goes up to this pin here, back out to this pin, down to battery ground. That makes this schematic here, effectively. And here's the PCB drawn up. I've made the traces thicker, put a ground plane on to help with any future corrosion. And there's the visual. So we have now the clone of this circuit board. And with it being related to fires and putting fires out, I figured we'd add a bit of style, turn the board red, add a little logo, and put where it was made by. Let's get this ordered by PCBWay. We just go to PCBWay. I'm just going to do a PCB, not an assembly, because we're going to assemble these ourselves. You can get a quote. We will upload the file, so we just need to enter the details here. And with it all uploaded and ready to go, I've paid for the 24-hour service, and it's been approved already. So now we just sit back and wait for these boards to arrive in the post. I'm excited to see the red colour, and then we'll get them assembled.